Welcome, stargazers, to Sleepy Space Facts, your cozy corner of the cosmos. Here, the vast universe becomes your bedtime story. Each episode is a quiet flight through space, where science soothes and facts flow like starlight. Tonight, we're gliding toward one of the most breathtaking worlds in our solar system, the majestic planet Saturn. So relax your shoulders, slow your breathing, and let your imagination drift through the golden rings of this distant giant. This is Sleepy Space Facts, where every fact helps you drift a little deeper into the universe and into sleep. If you enjoy these calming bedtime explorations, a gentle tap on the like and subscribe buttons would mean a lot. And for those already subscribed, thank you sincerely for being here again. Your support helps this sleepy little corner of the universe keep growing. If you haven't already, you may wish to click the notifications bell so you don't miss the next peaceful voyage. I do hope this video doesn't become too interesting and keep you awake longer than intended. But if it does, at least you'll float into tomorrow with a little more cosmic knowledge than you had today. Now, as you settle in, here's a thought to carry with you. How can a planet so gigantic, wearing shimmering rings that stretch for hundreds of thousands of kilometers, exist in a way that seems to make no sense at all? Saturn is often described as the jewel of the solar system. Yet the more we learn about it, the more it behaves like a celestial contradiction. Tonight's journey will gently explore why Saturn seems to break the rules, how it can be enormous yet strangely light, how its rings appear ancient and timeless yet may be far younger than we once imagined, and how a planet made mostly of gas can create storms, patterns, and structures with the precision of a cosmic clockmaker. We won't rush. We'll drift through each idea slowly, letting it settle like stardust. Together, we'll explore the serene beauty of Saturn's clouds, the delicate choreography of its icy rings, the curious behavior of its moons, and the quiet discoveries made by the spacecraft that studied it up close. As we begin this gentle voyage, keep one question tucked quietly in your mind. If Saturn truly shouldn't exist the way it does, what does that say about the universe that shaped it? Imagine that you're gliding through space in calm silence. There is no engine noise, no rush of air, no vibration beneath your feet, just stillness. Ahead of you, Saturn grows gently into view, wrapped in its delicate rings, like a lantern surrounded by frost. Starlight catches on the countless particles circling the planet, making them glimmer as though someone has dusted the cosmos with crushed diamonds. You drift toward them slowly, as if the universe itself is inviting you to take your time. As you draw nearer, the rings separate into recognizable bands of brightness and shadow, forming broad, graceful arcs that stretch across the darkness. From afar, they appear smooth and solid, almost like a single halo of polished glass. But as you approach, the illusion softens. The rings reveal their true nature, not a single surface, but a vast and intricate collection of icy fragments, each one dancing along its own orbital path. Some pieces are as small as grains of sand, while others are closer in size to a house. Together, they form a glittering ribbon that circles Saturn in a silent, perpetual ballet. Passing through the edge of the ring plane feels like drifting through a cloud of frozen lace. A soft haze surrounds you, illuminated by the faraway sun. The sunlight here has traveled for over 1,000 million kilometers to reach Saturn, arriving gentler and fainter than the sunshine we know on Earth. Yet even in this dimmer glow, the rings shine with quiet brilliance, as if the cold has polished them to perfection. From this close perspective, you may notice something surprising. For all their breathtaking width, the rings are astonishingly thin. They stretch across a distance so vast that if placed around Earth, they would reach far beyond the moon, yet vertically, they are no thicker than a few large buildings stacked atop one another. Imagine a sheet of paper spread across a football field. That's the kind of scale difference we're dealing with. The rings are like a cosmic whisper, wide, delicate, and almost weightless compared to the enormous planet they encircle. As your eyes adjust, 3 main bands of the rings become easier to distinguish. Closest to the planet is the C ring, faint and ghost-like, letting much of the faint sunlight slip through. Beyond it lies the B ring, the brightest and most opaque of them all, a sparkling band of densely packed ice that reflects sunlight like a beautifully frosted mirror. Further out, sweeping elegantly into the darkness, is the A ring, broader and slightly more translucent than the B ring, but still vivid enough to catch the eye. Separating the A and B rings is a notable dark gap known as the Cassini division, a subtle boundary where fewer particles drift. It isn't empty space, but it's sparse enough to appear like a deep breath between 2 bright brushstrokes of ice. These are the major rings visible from a farther sea, B, and each with its own brightness and texture. Beyond them lie subtle ringlets, wispy strands, and faint halos that reveal themselves only when curiosity draws you closer. For now, these 3 offer a gentle glimpse into the structure of Saturn's icy adornment without overwhelming the senses. The particles themselves are made primarily of water ice, often pure enough to gleam in the distant sunlight. Some contain a dusting of darker material, teeny flecks of cosmic debris and organic compounds that have settled over time. But at this soft introductory moment, the details don't need to be dissected too quickly. It's enough to know that the rings are made of countless frozen fragments circling Saturn in a graceful, ever-moving tapestry. Drifting among these particles, you might notice how peacefully they travel. There's no sound here, no crashes or clattering as one might imagine from a collection of countless orbiting objects. Collisions do happen, but space has a way of slowing chaos. When one fragment meets another, they nudge gently, transfer a little motion, and continue on their path. This delicate balancing act helps keep the rings looking so smooth and serene from afar. If you could hold one of these particles in your hand, assuming you could withstand the freezing temperatures and lack of oxygen, you might find it resembles a snowball, cold, compact, and glistening. Some fragments are fluffy and loosely packed, while others are solid and crystalline. Together, they create a scene that feels both familiar and otherworldly, like standing in a snowstorm made of crystal that never melts. What makes the experience so mesmerizing is the way the rings interact with light. Each tiny piece reflects and scatters sunlight, creating shifting patterns of brightness. When the sun is behind the rings, they appear translucent, glowing softly like frosted glass held up to a window. When the sun shines upon them from the front, they dazzle like freshly fallen snow. The effect changes as you move around them, turning the rings into nature's most subtle light show. As you drift just above the rings, Saturn begins to dominate your view. Its cloud tops appear smooth, striped with gentle bands of cream, gold, and muted gray. Shadows from the rings fall across the planet, painting elongated arcs of darkness over the atmosphere. These shadows add to the peaceful ambience, as if night and day have merged into a single tranquil canvas. The rings not only encircle Saturn, they cast patterns upon it like veils of shifting light. To the human eye, Saturn feels timeless, as if it has worn these rings since the dawn of existence. From this quiet vantage point, floating in the soft glow of reflected sunlight, it is easy to believe that the rings are ancient, unchanged, and eternal. They look so perfect, so complete, that it is hard to imagine the planet without them, yet appearances can be deceptive. The rings hold secrets that the universe has been patiently keeping, waiting for curious minds to notice that all is not as it seems. They may look everlasting, but their story is far more delicate than that. As we continue to glide above this icy halo, keep a quiet thought tucked away. How did such a thin, fragile formation appear around such a massive world? It seems almost too graceful to belong to something so huge. The answer lies in understanding Saturn's nature itself, and the curious balance that allows something so fragile to exist around a planet of such immense size. If you have spent any time around space enthusiasts, you may have heard a whimsical claim that Saturn is so light it could float on water. It is an image that tends to stay in the minder giant planetary rubber duck, bobbing cheerfully in a cosmic bathtub. It is a charming thought, but like many playful space facts, it needs a gentle unraveling before it drifts too far from reality. The idea comes from Saturn's average density. When scientists speak of density, they are referring to how much mass is packed into a certain amount of space. Saturn's density is surprisingly lower than water. If you were to compare them simply, Saturn is made of material that, on average, weighs less than the same volume of liquid water. So in theory, if you could find a body of water large enough, Saturn would float. However, practical difficulties with this image appear quickly. For one, there is no bathtub in the universe capable of holding a planet over 100,000 kilometers wide. And even if such a cosmic pool existed, Saturn would not stay politely intact as it drifted across the surface. Being a gas giant, it has no solid shell to rest on the water. Instead, enormous gravitational forces would distort the hypothetical ocean long before Saturn had a chance to demonstrate its buoyancy. The floating Saturn image is a delightful mental picture, yet the reality beneath it is far more interesting. Saturn is composed mainly of the two lightest elements in the universe, hydrogen and helium. These same elements make up the sun and most of the stars that shimmer in the night sky. On Earth we meet hydrogen and helium mostly in their gaseous forms. Helium fills party balloons and gives voices that comical high pitch when inhaled, though that is never recommended for safety reasons. Hydrogen is far more reactive, playing essential roles in chemistry and serving as the major ingredient in stars. Imagine a world made primarily of these airy, weightless elements, and you begin to understand why Saturn ended up with such a low density. Yet low density does not mean weak or hollow, nor does it mean Saturn is fragile. Saturn is still enormous. If Earth were a cherry tomato, Saturn would be a large beach ball beside it. Even though it is lighter in composition, its sheer volume means it holds a tremendous amount of mass. In fact, Saturn is over 90 times more massive than Earth, a staggering thought. A planet made mostly of the universe's lightest ingredients, yet still possessing a kind of weight and authority that Earth could never match. To better understand this contrast-like materials yet immense mass, imagine holding two objects in your hands. In one hand, a large marshmallow. In the other, a small bowling ball. The marshmallow is far bigger, fluffy, easy to compress, full of air. The bowling ball is tiny by comparison, but surprisingly heavy. Saturn is the marshmallow. In this analogy, huge but made of light materials. Earth is the bowling ball, smaller but packed tight with heavy elements like iron, oxygen, silicon, and magnesium. So although Saturn has a lower density, its sheer size ensures gravity still holds a firm grip across the planet. When we talk about gravity on Saturn, it may help to reflect on what gravity truly is. Gravity is not about how light or fluffy something feels. It is about how much mass it contains. Saturn has an enormous amount of mass, so its gravity is strong. If you could stand on its cloud tops, assuming you could, the pull of gravity would feel slightly stronger than it does on Earth. This might come as a surprise when you hear that Saturn's density is so low, but this is one of the first paradoxes Saturn offers. It is deceptively light in composition, yet remarkably powerful in pull. Saturn's interior is layered a bit like an onion, made of gas and liquid rather than rings of vegetable. The outermost part of the planet is an atmosphere rich in hydrogen and helium. As you descend, the gases become thicker and denser, gradually transitioning into liquid-like states under immense pressure. Deeper still, scientists believe there is a layer of metallic hydrogena, strange, shimmering form of hydrogen that behaves like a metal under crushing pressure. Beneath that lies a core thought to be composed of heavier materials, rock, metal, and ice mixed into a dense center. We cannot visit this core or send a probe to land there, because the pressure would destroy any spacecraft long before it reached that depth. But through models and measurements, scientists can picture it with reasonable confidence. Despite this layered complexity, Saturn lacks a solid surface. You cannot stand on Saturn the way you can on Earth or Mars. If you dropped through Saturn's clouds, you would pass through gas that becomes steadily thicker until it transitions into liquid. Deeper down, you would encounter extreme pressures and temperatures that would end any journey long before reaching what could be called the core. Saturn is a world defined by gradual change from gentle breezes at the top to crushing weight at the bottom. One reason Saturn maintains such a distinct shape is its rapid rotation. Saturn spins on its axis very quickly, completing a full rotation in just over 10 Earth hours. That is remarkably fast for a planet of its size. This rapid spin causes Saturn to bulge outward around its middle, resulting in a shape known as an oblate spheroid. In simple terms, Saturn is wider at the equator than it is from pole to pole. This bulging effect is not unique to Saturn. Earth experiences it too, though to a lesser degree. On Saturn, the effect is far more pronounced because of its quick rotation combined with its fluid, gaseous nature. If Saturn were a ball of dough spun on a baker's fingertips, it would stretch into a flattened form as it turns. The equator becomes its widest point, giving the planet a slightly squashed appearance. This shape influences everything from wind patterns to cloud formations. The rapid spin creates strong jet streams, which in turn form the gentle flowing bands of color that wrap around its surface. While we will drift deeper into the beauty of Saturn's atmosphere another time, for now it is enough to understand that Saturn's roundness is not as perfect as one might imagine. It has been sculpted by motion, stretched by speed, and shaped by the constant forces acting upon it. Another aspect worth appreciating is how Saturn's gravity interacts with its gravity is not just felt on the planet itself, extends outward, reaching into space. Saturn's gravity commands the movement of dozens of moons, a vast system of rings, and countless smaller particles caught in its pull. Though Saturn may be composed of light elements, it exerts a powerful influence. Imagine a large, gentle-looking creature that moves slowly and appears soft to the touch, yet holds an entire environment in balance simply by being present. Saturn is like that, serene on the outside, yet commanding by nature. The idea of a planet made of such lightweight ingredients, yet capable of shaping an entire miniature solar system, is part of Saturn's charm. It captures the imagination because it defies our instinctive expectation that big should always mean heavy, and that light should always mean weak. Saturn sits beautifully in between. It is light in composition, yet heavy-handed in influence. It floats in theory, yet anchors moons, rings, and space itself in reality. As you hold this thought, remember that the universe rarely conforms to our everyday experiences. A feather and a boulder behave differently on Earth, but across the vastness of space, the rules are both familiar and surprising. Saturn invites us to let go of assumptions and gently rethink what words like light, heavy, strong, and delicate really mean. Despite being made mostly of hydrogen and helium, Saturn is undeniably mighty. Its gravity shapes orbits, sculpts rings, and governs a family of moons like a patient conductor guiding a cosmic orchestra. And it does all this while being one of the least dense worlds in our planetary neighborhood. Saturn is a planet that appears soft and airy on paper, yet in space it holds authority light in substance. Immense in scale, graceful in form, and influential far beyond its cloud tops. It embodies a paradox that makes it one of the most intriguing of all planets. Light, yet remarkably strong. Gentle in composition, yet firm in presence, a planet that seems to defy logic, yet fits perfectly into the grand tapestry of our solar system. If you were to hover gently above Saturn's cloud tops, the first thing you might notice is how soothingly patterned the planet appears. Soft bands of color wrap around its curved surface, forming pale stripes of cream, butterscotch, and muted gray. These bands encircle the entire world, stretching all the way around like the brushstrokes of a careful painter working in calm, horizontal lines. From a distance, the effect is peaceful, almost dreamlike, as though Saturn is dressed in layers of softly woven silk. Yet beneath this tranquil appearance lies an atmosphere full of motion. Saturn is a world of winds, fast, flowing, and intricately organized. These winds move around the planet in long ribbons called jet streams. They travel mostly from west to east or east to west, forming alternating bands of direction. Where these bands meet, the atmosphere can swirl, twist, and churn in ways that both surprise and delight those who study it. The wind speeds on Saturn can reach astonishing levels, racing along at over 1,000 kilometers per hour near the equator. On Earth, a storm with winds that strong would be considered catastrophic. On Saturn, it is simply part of the daily rhythm. One of the reasons Saturn's atmosphere is so dynamic is that the planet rotates so quickly. It completes a full spin in just a little over 10 Earth hours. To put that into perspective, imagine Earth rotating twice as fast as it currently does. The change in our weather would be dramatic. Saturn, being much larger and spinning so swiftly, experiences tremendous forces in its atmosphere. This rapid rotation causes something known as the Coriolis effect, which influences how winds move and bend. On Earth, this effect shapes hurricanes and trade winds. On Saturn, it amplifies motion across a far greater scale, creating multiple jet streams and beautifully banded weather systems that span the entire planet. These bands of color that we see from afar are not painted onto a surface. They are the result of different wind speeds, temperatures, and cloud compositions at varying depths of the atmosphere. Each band has its own character, influenced by the complex behavior of gases swirling beneath. Because Saturn is made mostly of hydrogen and helium, its atmosphere does not behave quite like Earth's. Instead of a sky filled with water, vapor, and nitrogen, Saturn's clouds are composed of different ingredients that form layers, each one deeper and denser than the last. The highest clouds we see are primarily made of ammonia ice. These create Saturn's pale and often creamy white upper layer. Beneath them lies a second layer containing ammonium hydrosulfide, a compound that adds subtle tones of yellow and beige to Saturn's atmospheric palette. Deeper still, hidden beneath those upper decks, are clouds of water similar to Earth's clouds in composition, though the environment around them is far from familiar. These layers sit atop one another like tears in a gentle trifle, each adding its own flavor to the planet's overall appearance. Because each layer responds differently to temperature, pressure, and motion, Saturn's cloud systems shift, stretch, blend, and evolve over time. The seamlessness with which these layers interact gives Saturn its smooth, flowing look. If Jupiter sometimes resembles a turbulent oil painting filled with swirls and dramatic contrasts, Saturn is more like a softly blended watercolor where edges melt gently into one another. The result is quieter but no less captivating. Despite the calm look of Saturn's atmosphere, it is home to storms that can grow to truly impressive sizes. Saturn is no stranger to tempests that stretch for thousands of kilometers, sometimes wrapping around the entire planet in colossal bands of cloud. These storms can last for months or even years, slowly shifting shape as they travel along the jet streams. One particularly famous kind of storm is the Great White Spatter, recurring system that appears roughly once every Saturnian year, which equals about 29.5 Earth years. To us, that seems like a long wait between storms, but for Saturn, it is simply part of a slow, rhythmic cycle. When these enormous storms emerge, they can be spectacular. Bright clouds tower above the surrounding atmosphere and can be seen even from telescopes on Earth as large, bright smudges against Saturn's normally soft palette. Inside these storms, lightning flashes with a force that dwarfs anything seen on Earth. Each bolt can be hundreds of times stronger than a typical lightning strike in our skies. Because Saturn's atmosphere is thick and composed of different gases, lightning behaves differently too, glowing through the hazy layers and making the storm appear to pulse with light, though storms sound intense. Most of Saturn's weather patterns are steady and elegantly structured. The atmosphere tends to organize itself into sweeping flows rather than chaotic clashes. Even the great storms often merge smoothly into the planet's atmospheric tapestry instead of tearing it apart. Saturn's winds, despite their speed, have a rhythm to them, a sense of cooperation rather than conflict. They sweep across the planet in long, uninterrupted bands, sometimes merging, sometimes separating, but always maintaining the soft, striped appearance Saturn is known for. Because of this rapid rotation and layered cloud system, the colors we see are more subtle than many people expect. There are no deep reds or bright oranges like those that streak across Jupiter. Instead, Saturn wears the softer shades of sunrise pale golds, gentle creams, light grays, and occasional hints of pearl. These tones shift slowly over time as atmospheric conditions change, but the effect remains one of quiet elegance. It is as if Saturn has chosen a calmer wardrobe, one suited to a planet that prefers to whisper rather than shout. Beneath its beauty and calm, Saturn's winds reveal a world in constant motion. From equator to pole, each layer of atmosphere turns, twists, and hums with kinetic energy. Scientists often describe Saturn as an atmospheric engine because its entire upper layer behaves like a finely tuned system, converting heat, sunlight, and rotation into flowing currents that can last for decades. It is a reminder that calm appearances can hide endless activity beneath the surface. When we think of wind on Earth, we imagine breezes, rustling trees, or stormy gusts that bend branches. On Saturn, there are no trees to sway, no oceans to ripple, and no solid ground to feel the wind against. The winds we speak of are movements of gas and cloud gliding and streaming through a vast atmosphere with no true surface. If you could float alongside these winds, you would not hear a roar or a howl. There would be silence. The motion would be visible, not audible cloud bands flowing past like the slow unfurling of silk ribbons in a soft, steady current. This paradox of sensation, tremendous speed, paired with complete quiet adds to Saturn's aura of serene power. Everything on Saturn is exaggerated. Its size, its winds, its storms. Yet everything moves with grace. Even the most dramatic tempests become part of a greater harmony, turning the entire planet into a kind of cosmic orchestra where every current of gas plays its part in maintaining the balance. If you let your imagination drift for a moment, you might picture Saturn as a giant musical instrument, its jet streams like strings stretched across its surface, its storms like notes rising and falling over time. The whole atmosphere becomes a song, one that plays too slowly and quietly for human ears, but continues for centuries nonetheless. Winds that sing, clouds that dance, storms that write their stories across the sky. Saturn is, in its own way, a world of music without sound. While Saturn may appear calm and gentle from afar, its atmosphere is alive with energy, motion, and enduring patterns. These winds, these soft stripes, and these swirling storms tell the story of a planet shaped not by stillness, but by perpetual movement. Saturn's atmosphere is alive with flow, yet it never loses its quiet elegance. It is a masterclass in how a world can be powerful without being harsh and dynamic, without being chaotic. The next time you see an image of Saturn, notice the bands. Notice the smooth flow of color, the subtle blending, and the serene symmetry. Within those stripes lies the heartbeat of a giant, fast, rhythmic, and endlessly flowing. Saturn's winds tell a story of beauty in motion, of calm woven through speed, of a world where the atmosphere sings even if no one can hear the song. Near Saturn's North Pole, there is a sight so unexpected, so precise in its geometry, that for many years it left both astronomers and casual skywatchers blinking in quiet disbelief. It is a storm system shaped not like a circle or a spiral, but like a six-sided figure, a vast swirling hexagon, neatly formed as though drawn by a cosmic ruler. Gentle in color, yet striking in shape, this atmospheric pattern has become one of Saturn's most iconic mysteries. It is not loud or violent in appearance. Instead, it sits calmly at the pole, turning slowly and endlessly, as though the planet decided to wear a geometric crown. Imagine flying above Saturn's North Pole and seeing the shape below you. 6 smooth sides, each stretching thousands of kilometers, meeting at crisp angles. The hexagon rotates with the planet, maintaining its form year after year, behaving with serene stubbornness. Most storms in our solar system twist into circles because that is the most natural shape for rotating fluids. Yet here, at the top of Saturn, nature has done something beautifully unusual. It has folded movement into symmetry. When the hexagon was first captured in images during the early 1980s by the Voyager spacecraft, many people wondered whether it could possibly be real. It was so precise, so unlike anything ever seen on another planet, that some even suspected an illusion, a camera artifact, or, as a few imaginative thinkers mused, a structure that could not exist without help from some extraterrestrial architect. Fortunately, clearer images and later observations revealed the truth, one far more grounded and far more fascinating. The hexagon is not artificial, nor a visual trick. It is a natural phenomenon, born from physics and fluid dynamics, shaped by the motion of Saturn's atmosphere. To understand how such a shape can form, it helps to think about waves, not ocean waves, but waves that occur in fluids, including gases. When a fluid spins around an axis, its motion can settle into patterns, and sometimes those patterns break symmetry in remarkable ways. On Saturn, a jet of air flows around the North Pole, forming a powerful, steady current. Rather than circling smoothly in a perfect ring, the jet stream develops into a standing wave pattern. A standing wave is one that seems to stay in place, even though motion continues within it. You may have seen a simple version of this if you've ever shaken a skipping rope just right. It forms a wiggling pattern that seems to hold its shape even as the rope moves. Now, imagine wrapping that rope into a circle and picture the pattern creating peaks and troughs all the way around. Depending on the conditions, that circular wave can settle into 2, 3, 4, 5, 6, or more sections. On Saturn, the atmosphere has chosen 6. This standing wave, shaped and stabilized by Saturn's rotation, forms the hexagon. It is similar to how sound waves can create geometric patterns on vibrating surfaces, or how fluids on Earth, when spun and cooled, can sometimes form polygons. Laboratory experiments have successfully reproduced polygon-shaped currents on smaller scales, confirming that nature can indeed create shapes with corners in rotating fluids when conditions are just right. The hexagon is not a flat surface pattern painted on top of the clouds. It has height. It extends deep into Saturn's atmosphere and rises upward as well, forming a towering structure of wind and cloud. To picture it clearly, imagine a vast column of swirling air shaped into 6 sides, rotating around the pole like a slowly turning chimney of weather. Each wall of the hexagon is part of this immense current, and together they form a stable polygon that endures. The colors and appearance of the hexagon can shift with time. In some images, it appears pale gold and tan. In others, especially those captured in the early 21st century, it glows with bluish hues. These changes depend on lighting, the composition of clouds, and Saturn's long seasonal cycles. A Saturnian year lasts nearly 30 Earth years, meaning sunlight reaches the North Pole from different angles over decades. As a result, the hexagon's brightness and shading move through slow, graceful transitions. Yet even as its colors change, its shape remains steady and persistent. Most storms on giant planets are turbulent and short-lived compared to the worlds that host them. Jupiter's Great Red Spot is a famous long-lived exception. Yet even that swirling oval changes shape and color over the decades. Saturn's hexagon, on the other hand, holds its form with astonishing loyalty. It maintains its shape through years and through Saturn's full seasons. Long after it was first seen by Voyager, it was still there when later spacecraft returned for clearer views. Even now, observations show the hexagon turning patiently with the planet, subtle in motion. unwavering in outline. Why does this unusual shape remain so stable? The answer lies in the delicate balance between Saturn's rotation, the speed of the jet stream, and the layering of the atmosphere. The jet stream at the hexagon's latitude is fast and steady enough to maintain a standing wave. Small variations in speed, temperature, or density might break such a pattern elsewhere, but here conditions align in near harmony. The atmosphere flows, waves form, and geometry locks in. Because the hexagon is so visually striking, it has occasionally stirred public imagination with thoughts of alien engineering or coded messages. It is easy to see why a perfect geometric figure, tens of thousands of kilometers wide, calmly rotating atop a distant planet, does look intentional. But in truth, this is simply nature's elegance in motion, a demonstration that physics alone can produce beauty that rivals any design. The hexagon is the universe showing off its love of pattern. If Earth ever had a weather system with such symmetry, it would become one of the most studied phenomena in history. On Saturn, it sits quietly at the pole, turning through long polar nights and slow dawns, an atmospheric sculpture of breathtaking balance. When you think about Saturn's hexagon, imagine a candle flame. Most of the time, the flame flickers unpredictably, swaying and wobbling. But when air currents align just right, it forms a steady, still shape, impossibly still for something made of heat and motion. Saturn's hexagon is like that moment, movement balanced so perfectly that it freezes into form. There is a kind of quiet poetry in the fact that at the top of this giant swirling world, a shape of perfect symmetry has held its ground for decades. 6 sides, 6 edges, 6 steady paths of wind, meeting at crisp angles, geometry written in cloud and air. A pattern that would look at home in a snowflake or a honeycomb. Yet here it is, spanning a pole on a world so vast that Earth could fit inside it several times over and still not touch the edges. Saturn has a talent for defying expectation. Most people picture chaos in a storm, yet here we find precision. We imagine swirling curves and gaseous motion, yet here we see straight lines meeting at corners. The hexagon at Saturn's pole is not an artificial message or a sign of something beyond nature. It is the universe reminding us that order can arise from turbulence, that beauty can grow from motion, and that even in a place where winds roar at unimaginable speeds, there can be structure, steady, elegant, and wonderfully strange. So the next time you find yourself thinking that nature prefers randomness, remember Saturn's North Pole. Up there, beneath pale sunlight, a 6-sided storm turns unhurried and unwavering. A peaceful hexagon shaped by nothing more than the flow of air and the quiet laws of physics. It is one of the universe's most graceful surprises, a reminder that geometry and serenity can share the same space, even in the heart of a roaring planet. On Earth, the changing of seasons feels familiar and reassuring. Spring warms into summer, autumn cools into winter, and the cycle begins again. A full journey through all 4 seasons takes 1 Earth year, a rhythm so natural that we often measure our lives by it. Saturn, however, keeps a far slower calendar. A single year on Saturn, 1 full orbit around the Sun, takes nearly 29.5 Earth years. That means each season lasts more than 7 Earth years. Imagine winter lingering for nearly a decade, or summer stretching so long that children born at its start would be well into school before the next one arrived. On Saturn, the seasons unfold like a slow-motion ballet, too gradual to witness in a single glance, yet majestic when viewed across time. Just like Earth, Saturn has seasons because it is tilted on its axis. Saturn leans at an angle of roughly 26 to 27 degrees, very similar to Earth's tilt of about 23.5. This tilt means that as Saturn travels along its distant orbit, different parts of the planet receive more or less sunlight. Sometimes the northern hemisphere leans toward the sun, basking in long stretches of daylight. At other times, the southern hemisphere enjoys that same distant warmth. Between these extremes come more balanced periods, when neither half is favored. Although the mechanism behind Saturn's seasons is familiar, their pacing and scale are vastly different. If you could hover near Saturn long enough to watch a full Saturnian year unfold, you would see the planet's appearance gently shift as the seasons progress. One of the most striking seasonal effects can be seen not in the atmosphere alone, but in the behavior of the rings and the shadows they cast. Saturn's rings are not just ornaments circling the planet. They interact intimately with sunlight, creating mesmerizing visual changes throughout the year. Because the rings are so thin and wide, they cast long, sweeping shadows across the cloud tops below. These shadows behave like soft brush strokes, shifting, lengthening, fading, and reappearing as the angle of sunlight changes. During Saturn's solstices, when one hemisphere is tilted most strongly toward or away from the sun, the shadows of the rings stretch dramatically across the planet. Imagine watching dusk crawl slowly across a landscape. Except here, the landscape is a vast, gaseous world, and the shadows are drawn not by mountains or trees, but by icy rings suspended high above. At one solstice, the northern hemisphere is bathed in long sunlight, while the southern hemisphere rests in an extended twilight. Half a Saturnian year later, many Earth years after, the situation reverses. The hemisphere that once basked in sunshine falls into a long winter, while the other awakens under the distant glow of the sun. Because these seasons last so long, the concept of a sunrise or sunset takes on an entirely new meaning. A single spring on Saturn lasts about 7 Earth years. Dawn does not sweep quickly across the horizon, it creeps. The increase in light unfolds so slowly it could be described as a decades-long morning, a sunrise stretched so thin across time it would be impossible to notice in real time. If you were a Saturnian cloud, and what a thought that is, you might see sunlight gradually brighten over several Earth years. Spring would feel like a slow inhalation of warmth. Summer would be a long, steady glow, more like a sustained breath outward than a burst of heat. Then come the equinoxes, special times when Saturn's tilt aligns so sunlight strikes the rings edge-on. During an equinox, the rings appear to thin almost to invisibility from certain angles. The sun's light no longer falls across their broad, icy surfaces, but hits along their edge instead, because the rings are so extraordinarily thin compared to their width. This edge-on view makes them look like a near-invisible line dot at these moments. The rings cast almost no shadow on Saturn's surface. The great sweeping bands of darkness that normally fall across its clouds vanish, and the planet's atmosphere glows more evenly. For a brief period, brief by Saturnian standards, the planet wears no ring-shaped shadows at all. These equinoxes occur twice every Saturnian year, separated by about 15 Earth years. They also offer rare opportunities for scientists to observe the rings in detail. When sunlight shines directly along the plane of the rings, even small bends or ripples in their structure cast tall, narrow shadows, revealing subtle height differences that are usually hidden. It is one of the few times when Saturn's rings show their three-dimensional texture so clearly. Their icy lace illuminated edge-on by sunlight from billions of kilometers away. Solstices, on the other hand, bring contrast. When one hemisphere tilts most directly toward the sun, it experiences a long, lingering summer. The sun hangs higher in the sky, warming and illuminating the clouds for years at a time. Meanwhile, the opposite hemisphere slips into a deep, drawn-out winter, lit only by sunlight filtering through the rings or reflecting faintly from them. Sunlight becomes scarce. Shadows grow long. The atmosphere cools into an extended calm. If Earth experienced seasons like this, winter would not be a passing inconvenience. It would shape entire generations. On Saturn, these long seasons create slow, elegant changes in the planet's appearance. During the extended summers, the hemisphere turned toward, the sun may show subtle shifts in color as atmospheric layers respond to the prolonged warmth. Over years, the shades of gold and beige may gently alter as sunlight slowly works its way through the upper clouds. The effect is not dramatic like autumn leaves changing on Earth, but it is noticeable, a gradual change in tone, like watching a painter add a faint new layer of color over time. Because Saturn's year is so long, each visit we make reveals a slightly different face. The Voyager spacecraft saw one phase of Saturn's year in the 1980s. 15 years later, new spacecraft saw another. 15 years after that, yet another mood had emerged. Observing Saturn is like checking in with an old friend once a decade to see how they've changed. The changes are subtle but meaningful, an unfolding story told in slow motion. The rings themselves act like enormous sundials, marking Saturn's seasons, not in days or hours, but in decades. As Saturn moves through its orbit, the tilt of the rings changes the way sunlight filters down to the planet. During winter, the low sun creates long shadows that stretch across the clouds, while in summer, the same rings reflect sunlight back, brightening the atmosphere. Imagine a child born at the start of Saturn's spring in its northern hemisphere. By the time that child reached school age, summer would only just be beginning. They would grow into adulthood before autumn arrived, and winter might not come until they were well into middle age. On Saturn, a person could live an entire human lifetime without ever seeing a complete cycle of the seasons. Time itself feels different there. Slower, softer, measured in decades of shifting light instead of months. These extended seasons give Saturn a sense of patience. Nothing rushes. Change flows like syrup rather than water, thick, deliberate, and unhurried. The sunlight that falls on Saturn travels from far away, arriving weakly and softly. The sun appears much smaller in the sky than it does from Earth, and the warmth it gives is gentle. There are no sharp transitions, no sudden bursts of heat, no icy plunges overnight. Change moves like breath, like the turning of a page in an ancient, quiet book. There is something deeply soothing about a world where dawn lasts for years, where summer is a slow exhale, and where winter is not a fleeting chill but a long, tranquil slumber. Saturn feels like a planet built for dreamers, a world that refuses to be hurried. If Earth's seasons remind us of renewal and the cycles of life, Saturn's remind us of patience, of the beauty that comes from time stretched across the ages. Watching Saturn turn through its seasons is like listening to a symphony played so slowly you can feel each note fade into the next. The light shifts gently, the shadows drift softly, and the planet teaches a quiet lesson that not all change needs to be fast to be meaningful. Sometimes the most profound transformations are the ones that unfold quietly, over many years, with the grace of a sunrise that takes a decade to bloom. Long before Saturn shone as a golden jewel in our solar system, long before its rings formed their icy lace, and long before any of its moons gathered around it, there was only a cloud. Not a delicate cloud like those drifting across Earth's skies, but a vast, swirling disk of gas and dust encircling a newborn sun. The early solar system was a place of gentle chaos, warm, hazy, and full of drifting material illuminated by the faint glow of a young star that had only recently ignited into life. Within this great disk, called a protoplanetary disk, every planet, moon, asteroid, and comet began as something unimaginably small. The story of Saturn's birth begins with dust. That may sound humble for a world that would one day be wrapped in rings and cloaked in clouds. But dust is where nearly all planets begin. At first, this vast disk contained countless tiny grains, smaller than sand, made mostly of elements like silicon, oxygen, carbon, iron, and frozen water. These tiny fragments drifted together in the faint turbulence of the young solar system, colliding gently in the sunlight. When they touched, static forces helped them cling together, much like flowers slowly clumping in still air. Over time, these grains stuck and grew into larger pieces, first into small clumps, then into pebbles, and eventually into rocks. The journey from dust to something substantial was slow but steady. As these pieces grew, they formed what astronomers call planetesimals, objects large enough for gravity to begin to play a role. Once gravity entered the picture, growth accelerated. Gravity acts like a quiet invitation, drawing in more material, coaxing nearby objects to come closer. A planetesimal with even a little more mass than its neighbors has an advantage, because it can gather material more efficiently. In the early solar system, countless planetesimals competed for building blocks, growing whenever they could, and sometimes colliding with each other. Some merged into larger bodies, while others shattered, scattering fragments for new worlds to collect. Gradually, the seeds of planets took shape. But to become a gas giant like Saturn, a forming planet needed more than rock and ice. It had to grow large enough, quickly enough, to capture gas from the surrounding disk before that gas disappeared. The protoplanetary disk itself was temporary, lasting only a few million years before the young sun's radiation and solar winds blew it away. That may sound long, but for planet building, it was a ticking clock to capture gas in large quantities. A young world first needed a solid core, something with enough mass to pull in hydrogen and helium, the lightest and most abundant elements in the universe. This process is known as core accretion. In Saturn's case, the core likely formed from rock and ice until it reached several times the mass of Earth. Once that happened, its gravity became strong enough to draw in the surrounding gas. Imagine a snowball rolling downhill, gathering more snow as it moves and growing faster with each turn. Saturn's core did something similar, except instead of snow, it pulled in hydrogen and helium. As these gases streamed toward the growing planet, they wrapped the core in thick layers of atmosphere. Over time, Saturn's mass increased dramatically, far beyond its solid beginnings. In this way, Saturn transformed from a frozen seed of dust and ice into a world of gas surrounding a dense heart. Core accretion remains the leading explanation for how Saturn and other gas giants formed. But another idea sometimes enters the conversation: disk instability. In this scenario, Parts of the protoplanetary disk cool and clump together rapidly under their own gravity, forming giant planets in a relatively short time. Instead of slowly building a core and then gathering gas, the gas itself collapses into a planet directly, almost like the solar system folding briefly to create a new world. While this second idea paints a quicker, more dramatic origin story, most evidence supports the gentler, slower process of core accretion for Saturn. Still, the universe is vast, and in other planetary systems, both methods may occur. Some worlds may form suddenly, while others grow patiently, grain by grain. Over time, once Saturn formed, its story was far from over. Where a planet is born is not always where it stays. Planets can move. They do not drift freely across the solar system like balloons on a breeze, but gravitational interactions can nudge them from there. Birthplaces, gas giants in particular, can migrate during their formation if they interact with the gas of the disk, with other forming planets, or with leftover debris. This migration is not a single event, but a gradual shift over millions of years, subtly changing a planet's orbit. Looking at Saturn today does not guarantee that it was always there. Many astronomers believe the giant planets, Jupiter, Saturn, Uranus, and Neptune, may have been born closer together than they are now. Early models of the solar system suggest gravitational interactions between them pushed and pulled the giants, until they settled into more stable orbits. Saturn's relationship with Jupiter, in particular, may have played a key role. The two massive worlds likely influenced each other's movements, like dancers adjusting their steps to avoid a collision. As they interacted, their orbits shifted, reshaping the solar system around them. Some models even suggest that the early motions of Jupiter and Saturn helped sculpt the inner solar system, influencing how material was distributed and how worlds like Earth and Mars eventually formed. In that sense, Saturn was not just finding its place, it was helping to shape the architecture of the entire solar system. It's fascinating to imagine that the position of our own planet might have been influenced by how Saturn drifted through space during its youth. As the protoplanetary disk gradually faded, the planets found more stable paths, and Saturn settled into the region it now occupies, far from the Sun, where sunlight is dim and temperatures low. These cold conditions helped Saturn retain its thick atmosphere of hydrogen and helium instead of losing it to space. Closer to the Sun, that same gas would have been harder to hold on to. In many ways, Saturn's current location allowed it to keep its identity, a vast, gaseous world wrapped in clouds, adorned with rings, and surrounded by dozens of moons. Had Saturn formed nearer the Sun and not moved outward, its story might have been very different. The environment of the outer solar system provided Saturn with both space and stability. It sits far enough from the Sun that its gases remain cool and bound, yet close enough that sunlight can still reach its clouds and make them shine. It lives in a region that, during formation, was rich in icy material, the very ingredients that helped its core grow and later contributed to the birth of its moons. Here, Saturn could flourish, becoming the majestic planet we know today. When we tell the story of Saturn's birth, it's easy to imagine a smooth, intentional process. Dust becomes pebbles, pebbles become rocks, rocks become a core, and the core becomes a gas giant. But the truth is both more chaotic and more poetic. Saturn exists because of a delicate balance of chance, timing, motion, and cosmic conditions. A little more heat, and the disk might have lost its gas too quickly. A little less material, and the core might never have formed. A slightly different gravitational dance, and Saturn could have ended up elsewhere, or not formed at all. There is something quietly comforting about knowing that a world so grand began as tiny flecks of dust floating in space. It reminds us that even the most magnificent structures in the universe start small and unassuming. Growth, whether of planets or of people, often begins quietly. Saturn's journey from dust to giant is a lesson written into the very fabric of the solar system. That time, patience, and the gentle pull of gravity can transform the simplest beginnings into something extraordinary. Now that Saturn has settled into its orbit, circling the distant sun in calm rhythm, it is time to turn our attention to what makes it so unmistakably beautiful: its rings. These radiant bands of ice and shadow have fascinated humanity for centuries. From the first time they were glimpsed through a modest telescope to the high-resolution images captured by modern spacecraft. From a distance, Saturn's rings look like a single, flawless disk, thin, gleaming, and smooth, as though someone had painted a delicate circle of light around the planet. But as we have already seen, this illusion dissolves up close. The rings are not solid at all. They are made of countless icy particles, each following its own path around Saturn, moving in harmony under the planet's gravity. These particles range in size from microscopic grains of dust to chunks as large as houses, though most are closer to snowflakes than boulders. Each fragment reflects sunlight in its own way, giving the rings their shimmering appearance. When sunlight strikes them, they sparkle softly, like a field of frost beneath the glow of dawn. The rings are named in the order they were discovered, not by their distance from the planet. Moving outward, the main ones are the D, C, B, A, F, G, and E rings. The C, B, and A rings are the brightest and easiest to see, forming the striking banded structure visible even through small telescopes. The B ring is the thickest and most reflective, while the C ring is fainter and more transparent. Separating the A and B rings lies a wide, dark gap called the Cassini division, named after the astronomer Giovanni Cassini, who first observed it in the 17th century. This division is not empty space, but a region where fewer particles orbit. The gap was created by gravitational interactions with one of Saturn's moons. Mimas, the moon's gravity pulls rhythmically on the particles that orbit within that region, gradually clearing it out over time. This process, called a resonance, shows how the dance of Saturn's moons shapes and maintains the structure of its rings. Beyond the A ring lies the narrow and complex F ring, a fine, twisted band that behaves unlike any other. The F ring is delicate and dynamic, continually reshaped by the gravitational influence of two nearby moons known as shepherd moons. These small moons, named Prometheus and Pandora, orbit on either side of the F ring, using their gravity to keep its particles in line as they move. Prometheus and Pandora tug gently at the edges of the ring, creating ripples, knots, and braids in the stream of ice. Imagine two hands guiding a ribbon through water, causing waves that twist and shimmer but never completely fall apart. That is what happens here, on a scale measured in thousands of kilometers. The result is a ring that is alive, never quite the same from one orbit to the next, yet always recognizable. Farther out still lies the E ring, a faint and diffuse halo stretching farther from Saturn than all the others. Unlike the dense inner rings, the E ring is made of fine, almost invisible particles. It owes its existence to one of Saturn's most remarkable moons. Enceladus is a small, icy world that hides a secret beneath its frozen crust, a global ocean of liquid water. This ocean occasionally vents through cracks near the Moon's south pole, sending plumes of water vapor and ice particles into space. These jets, illuminated by the distant sun, form a fountain that continuously feeds the E-ring. Every time Enceladus releases a burst of icy vapor, it renews the ring, ensuring that the E-ring remains fresh and bright. It is one of the most beautiful examples of cooperation in the solar system, a moon sustaining a ring, and a ring revealing the activity of its moon, closer to the planet. Within the faint D-ring, and even beyond the G-ring, lie subtle structures visible only to spacecraft. These wispy, transparent regions are full of delicate threads of ice and dust. Together, they form an intricate system that behaves more like a living organism than an inanimate feature. The rings are constantly shifting, particles colliding, breaking apart, and reforming a slow, graceful choreography that has continued for millions of years. But where did these rings come from? How did Saturn acquire such a magnificent adornment when no other planet in our solar system has anything quite like it? Jupiter, Uranus, and Neptune also have rings, but theirs are dark, thin, and difficult to see. Saturn's rings, by contrast, are broad, bright, and unmistakable. For a long time, scientists believed the rings were as old as Saturn itself, leftovers from the formation of the planet billions of years ago. In that view, they were a permanent feature, as ancient as time. However, more recent evidence has challenged that picture. Measurements from spacecraft like Cassini suggest that the rings may be far younger, perhaps only a few 100 million years old, or even less. If that is true, then the rings are relatively recent in cosmic terms, younger than the dinosaurs that once walked the Earth. This idea has transformed the way we think about Saturn. Instead of being a world that has always worn its icy crown, it may have acquired it late in life, after the solar system had long since settled. So how could such rings have formed? Several theories compete for that answer. One possibility is that Saturn's rings were created when one of its moons ventured too close and was torn apart by gravity. There exists a boundary around every planet called the Roche limit, named after the French astronomer Édouard Roche. Inside this limit, tidal forces from the planet's gravity become stronger than the self-gravity holding a moon or large object together. If a moon crosses that boundary, it can literally be pulled apart, its material scattering into orbit as countless fragments. Over time, those fragments would spread out, forming rings. This process is dramatic but entirely natural, a gentle destruction that leads to beauty. The resulting material would gradually sort itself by size and orbit, eventually creating the structured bands we see. Today, another possibility is that the rings formed not from a moon's destruction, but from the remnants of a large comet that wandered too close to Saturn and broke apart. The icy nature of the rings supports this idea, since comets are made mostly of ice and dust. A shattered comet could have left behind the same kind of debris that now circles Saturn in silent orbit. A third theory suggests that the rings could be made from leftover material that never formed into a moon at all, building blocks that lingered near Saturn since its early days. According to this view, the rings are a kind of frozen relic, a museum of ice showing what the early solar system's raw materials looked like, regardless of how they formed. Saturn's rings are not static. They evolve over time. Micrometeorites, tiny pieces of rock and dust drifting through space, constantly strike the ring particles, darkening them gradually. Some of the icy material slowly falls towards Saturn, forming a faint drizzle of particles that rain into the upper atmosphere. Cassini's final observations, before it ended its mission, showed this ring rain in action. It revealed that Saturn's rings may one day fade away entirely, slowly losing their brilliance as particles fall inward. It is a humbling thought that something so vast, so breathtaking, and so seemingly eternal is, in fact, temporary. The rings we see today are a fleeting chapter in Saturn's long story. But fleeting does not mean insignificant. The rings, though perhaps young, have become part of Saturn's identity, its face to the universe. They remind us that beauty can arise not from permanence, but from impermanence. The very fact that the rings may not last forever makes them more precious. Perhaps 100 million years from now, another civilization might look toward Saturn and find a quieter, plainer world. The bright ribbons of ice may have faded, the light may have dimmed, but for this brief era, in cosmic terms, Saturn shines, adorned in elegance, in a universe that measures its life in billions of years. Saturn's rings are like a flash of light, a moment of frozen music, caught in the act of being beautiful. If Saturn's rings are its crown, then its moons are its court, a diverse and loyal family of worlds that orbit, influence, and accompany their parent planet through the vastness of space. Saturn has more known moons than any other planet in our solar system, each one unique in character and history. Some are tiny, no larger than mountain ranges on Earth, while others rival small planets in size. As of today, astronomers have confirmed over 80 moons orbiting Saturn, and there may be even more that have yet to be discovered. Each one contributes to the complexity of Saturn's system. Some shape the rings, others sculpt the magnetic fields, and a few hold mysteries that could one day deepen our understanding of where life might exist beyond Earth. Among this great family, one moon stands above all others, Titan. Titan is Saturn's largest moon, bigger even than the planet Mercury. It is the second largest moon in the solar system, only slightly smaller than Jupiter's Ganymede. But Titan is far more than a simple sphere of rock and ice. It is a world with its own atmosphere, weather, and surface features. In many ways, Titan behaves like a small planet orbiting a larger one. Titan's atmosphere is thick and golden, made primarily of nitrogen, the same gas that dominates Earth's air. But unlike Earth, Titan's skies are hazy with methane and complex organic molecules. These hydrocarbons form layers of mist that give Titan its warm orange color when viewed from afar. The haze scatters sunlight so thoroughly that the surface below receives only a faint diffuse glow, similar to the light on a cloudy winter afternoon. For centuries, no one could see what lay beneath that veil. It wasn't until the arrival of the Cassini-Huygens mission that Titan's true nature began to reveal itself. When the Huygens probe descended through Titan's atmosphere in January 2005, it sent back the first images of a landscape that looked strangely familiar: valleys, hills, and channels carved by flowing liquid. But this was not water. On Titan, the liquid that shapes the surface is methane and ethane, hydrocarbons that are gases on Earth, but behave like water in Titan's cold environment. The temperatures on Titan average around 179 degrees Celsius, so water there is frozen as hard as rock, forming mountains and bedrock. Yet methane, which would evaporate instantly on Earth, flows freely in this freezing world. It rains from the orange clouds, fills rivers, and gathers into vast lakes and seas. This means that Titan has a methane cycle, much like Earth's water cycle: evaporation, condensation, and rain. Clouds drift, storms form, and lakes rise and fall with the seasons. Imagine standing on Titan's surface, a strange, dim landscape lit by a distant, tiny sun. The horizon would glow softly through an orange haze. You might see dark, mirror-smooth lakes stretching into the distance, with methane rain gently falling, splashing onto solid ice that acts as rock. The air, though unbreathable for humans, would be thick enough to make you feel the weight of the atmosphere pressing gently around you. You could spread your arms and almost float, since Titan's gravity is only about 1/7 that of Earth's. The largest of Titan's seas is called Kraken Mare, named after the mythical sea monster. It stretches for hundreds of kilometers, filled not with water, but with liquid methane and ethane. Nearby lies Ligeia Mare, another great sea, dark and mysterious. These bodies of liquid reflect sunlight faintly, creating a dim shimmer that must look haunting and beautiful under Titan's orange sky. Titan's weather is dynamic. The methane rain does not fall constantly, but when it does, it can reshape the landscape, carving channels and washing sediment into lakes. Scientists studying Titan often describe it as a frozen Earth, not because it is warm or alive, but because it follows similar geological and meteorological rhythms. It has rivers, lakes, and seasons. It even has dunes made of organic grains that stretch across its equatorial regions like deserts of black sand. What makes Titan particularly fascinating is what may lie beneath its icy crust. Evidence suggests that deep below the surface, under many kilometers of frozen water, there could be a hidden ocean of liquid water mixed with ammonia. If true, this ocean might provide an environment where the ingredients for life could exist, not life as we know it. Perhaps, but something exotic, shaped by chemistry utterly alien to our world. Titan, in that sense, is a bridge between the familiar and the unknown. It looks alien, but feels strangely Earth-like in its patterns. Standing on its surface might feel like stepping into a dream where the laws of physics are subtly shifted, where rivers are made of gas and rocks are made of ice. Yet the flow of weather and erosion follows rules we recognize. Another of Saturn's moons, though far smaller, holds an equally astonishing secret. This is Enceladus, a world of dazzling whiteness. Only about 500 kilometers across, Enceladus is one of the most reflective bodies in the solar system. Its icy surface bounces sunlight back so efficiently that it shines like a cosmic pearl against the dark backdrop of space dot for many years. Enceladus seemed like a quiet, frozen sphere. But when the Cassini spacecraft flew past it, something remarkable was discovered. Near the moon's south pole, huge plumes of water vapor and ice particles were erupting into space, fountains of material jetting hundreds of kilometers high. These geysers revealed that beneath Enceladus's icy shell lies a global, the ocean of liquid water kept warm by tidal forces, the gentle stretching and squeezing caused by Saturn's gravity as Enceladus orbits. This discovery transformed Enceladus from an icy curiosity into one of the most promising places in the solar system to search for life. The plumes contain not only water, but also salts and organic molecules, ingredients associated with biology on Earth. Cassini even flew through these plumes, sampling them directly, confirming the presence of materials that hint at hydrothermal activity on the seafloor below. Imagine, deep beneath that frozen crust, dark ocean water moving slowly over a rocky seabed, warmed by vents that release heat and minerals. On Earth, such hydrothermal vents teem with life, tiny organisms that thrive without sunlight, feeding instead on chemical energy. If something similar exists on Enceladus, it would mean that life can begin in far more places than we ever dreamed, even if no life exists there now. Enceladus shows us that the ingredients for it, water, energy, and organic compounds, are not rare. They can appear even in the cold outer reaches of the solar system. That thought alone is profoundly comforting, suggesting that the universe may be sprinkled with potential oases, waiting quietly beneath ice and shadow. Other moons in Saturn's family tell stories of their own. Mimas, often compared to the Death Star from the Star Wars films because of its enormous impact crater, looks battered but calm. Tethys and Dione show evidence of ancient fractures, frozen relics of geological activity long since gone still. Rhea, pale and cratered, may hold thin layers of atmosphere clinging faintly to its surface. Then there is Iapetus, a moon that defies simplicity. One hemisphere is bright and icy, while the other is as dark as coal. This stark contrast makes it look as though someone has painted half the moon in shadow. Scientists believe that dark material from another moon or ring system may have settled on one side of Iapetus, altering its reflectivity. The result is one of the most visually striking objects in the Saturnian system. And finally, Hyperion, a moon that tumbles chaotically through space, spinning unpredictably as it travels. Its surface is filled with deep, sponge-like craters, giving it a texture unlike any other known moon. Hyperion seems to defy order, moving in an irregular dance that feels more like drifting than orbiting. Each of these moons, from Titan's orange haze to Enceladus's shining fountains, tells part of Saturn's story. They are companions, witnesses, and participants in the planet's long, quiet journey around the sun. Together, they form a miniature solar system, complete with oceans, mountains, storms, and mysteries. When you think of Saturn, try not to imagine it as a single planet alone. Picture it instead as a grand celestial family, a planet with dozens of children, each with its own voice, its own weather, its own personality. Some whisper softly through icy rings, others sing through geysers of vapor, and a few, like Titan, keep their secrets behind veils of orange mist in the darkness of space. Saturn and its moons turn together, not hurried, not silent, but steady. Their gravity binds them to one another in a delicate harmony that has lasted for billions of years. It is a family held together by invisible threads, a cosmic symphony conducted by the planet's gentle pull. And so, as we leave Saturn behind for tonight, let the image of that quiet, golden world linger softly in your mind. Picture its rings shining faintly in the distant sunlight, circling a planet that turns without hurry. Far away from Earth's noise and motion, Saturn moves with infinite grace, its rhythm unbroken for billions of years. It is humbling to think that all this beauty exists so far away, untouched and unseen by human eyes, except through the lens of science and imagination. Yet even from that distance, Saturn connects to us. Its pull on our curiosity, its calm endurance, and its balance of power and stillness remind us that we too are part of the same vast design. Every atom that makes up Saturn's rings, its clouds, and its moons once drifted through the same cosmic nursery that gave birth to the sun and the earth. The hydrogen that glows in its atmosphere is the same hydrogen that burns in our star, and the water that freezes on its moons contains oxygen older than the solar system itself. In that way, Saturn is not separate from us, it is family. It is another expression of the same universe that shaped us. Looking at it is like looking into a mirror made of light years and ice, seeing our origins reflected back through time. And perhaps that is what makes Saturn so deeply peaceful to behold. It doesn't shout its presence or demand our attention. It simply is. It shines in stillness, reminding us that even in the farthest reaches of darkness, harmony can exist. When you think of Saturn, remember that every world in the sky is part of a larger story, a story of formation, transformation, and persistence. Worlds like Saturn teach us patience. They remind us that creation does not happen in moments, but in eons. That beauty can take billions of years to bloom, and that the universe never hurries, even as it keeps moving forward. Somewhere right now, beyond the glitter of our own atmosphere, Saturn continues to turn. The sunlight that touches its rings left the sun over an hour ago, traveling across the emptiness of space before brushing those icy arcs. The particles in those rings glint for a moment and then continue their orbit, silent, steady, and eternal. Perhaps one day, far in the future, humans will stand on one of Saturn's moons and look up at that immense band of light stretching across the sky. Perhaps they will listen to the soft wind sweeping over Titan's dunes, or watch the geysers of Enceladus rise like silver mist against the stars. And perhaps, as they stand there, they will feel the same calm you feel now, that deep, wordless sense of wonder that comes from realizing you are part of something vast, ancient, and beautiful. Until that time, Saturn will wait. It will keep its quiet vigil at the edge of our sight, circling the sun in slow, patient rhythm. Its rings will continue to shimmer, its moons will continue to orbit, and its storms will continue to swirl like thoughts in a dream. When you close your eyes tonight, imagine yourself drifting through that space, past the soft arcs of the rings, past the golden clouds, past the moons suspended in blackness. Feel the silence of it all, the weightless calm of a world too beautiful for words. Let the thought of Saturn be your lullaby, a song without sound, carried by light and gravity across the dark. A reminder that even in the coldest corners of space, there is poetry. Even in the stillness between stars, there is motion. Even in the vast silence of the universe, there is peace. And as you breathe more slowly, let that peace settle over you. Imagine floating above the planet's gentle curve, the sunlight dim and warm on your face, the rings glinting softly below. You are weightless, timeless, safe in the quiet of your own room. You are drifting with Saturn now, calm, steady, and endless. The world grows softer around you. Thoughts become light, like the particles in the rings, each one circling gently until it fades into the whole. Sleep comes slowly, as softly as shadow on Saturn's clouds. The golden planet turns beneath the silent sky. The rings shimmer once more, and then, quietly, they vanish into the dark. Good night. May your dreams be wide, your heart light, and your rest as deep and serene as the stillness of Saturn.